In this video, we are going to record a complete case of multiple regression in SPSS. In this case, we are going to predict the participants' stress level with the help of the two predictors. One of them is PCOISS, personal control of internal state, and the second variable is the external control on events, which is a mastery control. So mastery control and personal control, these are the two predictors, and we are going to predict the stress level with the help of these two predictors. This complete case is to be described and analyzed in this recorded lecture. Before going to start the complete case, I want to review the regression model. There are the two broad categories of the regression model: simple regression and multiple regression. Simple regression has one predictor and one response variable. That means we have one dependent variable and one independent variable. But in multiple regression, we may have the many predictors. So if we have one predictors, the simple regression is there. If we have a multiple predictors, so this example that we are going to complete here is an example of multiple regression because it has two predictors. One of them is PCOISS, personal control of internal state, and second variable is the external control, which is a mastery control. These two predictors are to be used to predict a response variable, and the response variable is the stress level of the participants. Multiple regression and simple regression both can be splitted into the linear and non-linear version. So we are going to describe a linear version of the multiple regression here. The simplest model will be described as y is equal to beta naught plus beta 1 x1 is the first predictor plus so on. If we have the k number of predictors, then the second last term will be the beta k xk plus L. This model is known as multiple linear model, or we can call it as a multiple regression with the two or more predictors. So we have k number of predictors in this model. Y is the response variable, betas are the parameters of the model, and there is a random factor in the model. That random factor is known as the error term. These are the assumptions of multiple regression. Sample size should be sufficient. As many number of predictors we have to increase the sample size. Some statisticians gave different suggestions about the selection of the sample size. Some are saying that 50 plus 8 times number of predictors in the model we have. Suppose we have the 5 predictors, then 5 multiplied by 8 plus 50 will be the sufficient sample size. There are the different suggestions, but user can opt any of the suggestions by the statisticians for analyzing the sample size. Multicollinearity and singularity, these are the two important issues. The dependent variable and the independent variable have a strong correlation among themselves. But multicollinearity is an issue in the multiple regression whenever we have predictors have a strong significant correlation. If the predictors have a strong significant correlation, that issue in the multiple regression is known as the multicollinearity. So we avoid the multicollinearity. It is suggested that the multicollinearity should be avoided. Singularity and multicollinearity in somewhat extent similar, but singularity means that we have the few predictors in the model which are computed or calculated with the help of the other predictors. Suppose we are saying that the age of car and Another predictor we have is the registration year. The registration year, with the help of registration year, we can predict, we can calculate the age. If I subtract the current year and the registration year, then the age of car will be determined. So if we are keeping these two both variable into the model, that will cause an issue into the model, and that issue is referred to as singularity. So we have to avoid such issues. Multicollinearity we should have to avoid, singularity we should have to avoid. How the user can avoid these two issues into the multiple regression? By excluding any one of these two variables. So I think age is appropriate as compared to the year registration year. That is that will play multicollinearity or the singularity into the model. Outliers should be removed. Extreme numbers should always be removed before going to implement the regression model. Other issues are what? Normality. The variable in the analysis should be normally distributed. All variables. The dependent variable should be normally distributed, and all predictors are normally distributed. Linearity means if we are implementing a multiple linear regression, then the scatter plot should have an indication of linearity. If the scatter plot is indicating a non-linear model, so we cannot implement a linear model onto a non-linear scatter plot. Homoscedasticity means the variances of the all variable in population must be same. So the Levene test should be applied for testing the homoscedasticity or the equality of variances. The independence of residual means the different values of the residuals should not have correlation among themselves. That type of correlation is known as the autocorrelation. So there should not be the autocorrelation into the residuals. So these are the assumptions. If the assumptions are fulfilled, then we can apply the process of multiple regression. Otherwise, if we apply the multiple regression, if the assumptions are not fulfilled, then the accuracy of the prediction will affect. In this example, or in this case, we are going to use the data file which is given to you, survey 5ED. In this data file, we have several variables, but we have to focus upon the three important variables. One of them is respondent perception of control. Respondent perceptions of control, we are taking the two important control here in this analysis. One of them is the mastery control, and other of them is PCOISS, personal control of internal state. These two are the predictors, and the one variable we have as a response variable or a predicting variable. That variable is called perceived stress. So what effect do we have of these two mastery control over the stress? So this is to be analyzed in this complete analysis. The two variables are described here, which are the predictors. Mastery scale, measure the degree to which the people feel they have control over the events in their lives. So this is to be assumed as a external control. And PCOISS is the another variable, which is the control of internal state, emotions, the thought, and the physical reactions. These are the important actions of the persons by which we can predict, or we can have the value of PCOISS. So these two predictors are there, and we want to complete and analyze the variable, which is stress, perceived stress. The three variables totally are used here in this analysis. We can extend the analysis by including the more predictors, but initially I complete this analysis with the help of these three variables. So TP stress in the data file is a variable which will be used as a dependent variable. PCOISS, TP, total perceived control of internal state. And TMAST is the total mastery control. So these two are the predictors, PCOISS and TMAST. And TP stress is a response variable and the dependent variable. We can also include two more variable after the basic model. That two variable are what? Social desirability and age of the participants. Whether the age is impacting on the stress or not, or the social desirability factor is impacting on the stress or not. So that two predictors you can include in the analysis after the basic model. What are the research question? The research question is how well do the two measure of control, mastery, PC and PCOISS predict the perceived stress? What impact of these two predictors we have on the stress? The second question is, which is the best predictor of perceived stress, the PCOISS or the mastery scale? We can pose the research question by these two ways. This is the procedure that you can implement in SPSS. Just click on the analyze and select the linear regression from there. Then dependent variable is to be chosen and independent variable are to be selected in the independent box. The independent variables are PMAST and PCOISS, and dependent variable is the TMAST is the first predictor, and the total perceived control of internal state is the another predictor, and dependent variable is the perceived stress, TP stress. So this is the selection of variable. So in the dependent box, you have to select one variable, and in the independent box, you have to select the two variables. The method should be entered. There are the several methods of implementing the regression into the SPSS, but the basic method is to use enter. Enter method means these two variables will be included directly into the model. In the statistics button, we have to click on the several options: estimate, confidence interval, model fitting, descriptive measures, part and partial correlation, and collinearity diagnostic. In the residual section, we have to select the case-wise diagnostic and the outliers outside 3 standard deviations. If we have some numbers which are away from the 3 times of a standard deviation, that should be assumed as an outlier. In the missing values section, we have to exclude cases pairwise and click continue. In the plot segment, you have to click on the standardized residual plot. The normal probability plot is to be selected. And lastly, we have to click on the 2 types of distances, the Mahalanobis distances and the Cook distances. These distances will help us to determine the several factors of errors. Okay, whether error is fulfilling the standard standard assumptions or not. These are the settings in SPSS. After clicking the OK and the continue button, we will have the outputs of the regression model. The first output in the regression model is the correlation matrix. In this matrix, we have 3 important segments. In the top segment, we have a matrix of 3 by 3 in which the values of correlations are mentioned. In the second row, we have p-values against all of these correlations. And in the third row, we have sample sizes. So you can see that there are unequal sample sizes in the list. The reason is if we are analyzing total perceived stress, with the total perceived stress. In the total perceived stress, we have a 433 observations. In the variable 4 mastery control, we have a 436 observation. In the variable PCOISS, we have a 431 observations. So different variable have different number of observations. Whenever we are using total perceived stress with the mastery control, so we are using 433 observations. This is due to the selection of missing numbers, exclude missing numbers pairwise. Pairwise means in these two pairs of variable, whatever is the minimum value will be used here. The correlation, you can see the correlations are 1 in diagonal. Why the correlations are 1 in diagonal? The reason is these are the correlation among themselves. The correlation of perceived stress with perceived stress is 1. Correlation of total mastery with the total mastery is also 1, and so on. The 100% correlation we have. We have not to read the lower diagonal matrix. The reason is this is the replica of the upper diagonal matrix. So only the three correlation are to be analyzed. One of them is the correlation among the perceived stress and the mastery control is 0.612. And the correlation between the perceived stress and PCOISS is minus 0.581. Impact is what? Mastery control will reduces the stress. The negative sign is indicating that the higher value of the mastery control, the producing a lower value on stress, means we have a small stress if we control events in a regular basis. In the same way, if we are having a higher control on internal state, that is also producing a small values of the stress. So these two correlations are negative. The reason is these two correlations are impacting um, the stress in a negative pattern or inversely proportional. These two variables are with the perceived stress. But one correlation is positive. This correlation is 0.521. It is the correlation among the total mastery and the PCOISS. Total mastery is a predictor and PCOISS is another predictor. There is a positive correlation among these two. The meaning what? Meaning that if a person have a higher control on the external event, so it should have a higher control on the internal event. So the persons have a higher control on the internal event, that is indicating that they have a higher control on the external event. There is a positive correlation. Which of these three correlation are significant and which is not significant? So we can observe these three p-values. Every p-value have a hypothesis behind that. So I'm writing the hypothesis regarding this p-value, 0.000. All the p-values are 0, meaning that all correlations are significant, but with the help of null hypothesis and alternate hypothesis, I am explaining that. Three hypotheses are shown against these three p-values. The first hypothesis is related with the 1,2. 1,2 means what? The perceived stress and the mastery control. The correlation between the perceived stress and mastery control is 0 in the population and is not 0. That is indicated with the red color. The p-value, which is indicated by the black color, have a hypothesis that the rho 1,3 is equal to 0, meaning that the population correlation between the perceived stress and PCOISS is 0, and it is significant in the alternate hypothesis. With the green font, I used to write down the correlation between the mastery control and the PCOISS, which are the two predictors. So this correlation, which is indicated by the green, if it is very high, like 0.8 or above, so this may cause multicollinearity. But these two correlation must be a stronger correlation, and that if they are stronger correlations, then will gives us a better control on perceived stress. So higher correlation between the independent and dependent variable will gives us a better model, and the higher correlation between the independent variable will causing a problem into the multiple regression. That problem is multicollinearity. The p-values are 0, 0, 0, which all p-values are smaller than level of significance, which is 0.05, if I assume. Then we reject all of the three null hypotheses. So this null hypothesis is rejected and alternate is selected. This is rejected and this is selected. Means we have a significant correlation in between the perceived stress and the mastery control. We have a significant correlation in between total perceived stress and PCOISS. Still, we have a significant correlation between uh, PCOISS and the mastery control. So the three alternate hypotheses are true and the three null hypotheses are rejected. So this is rejected, this is rejected, and three alternate hypotheses. These p-values are indicating that. Another important table into the multiple regression is the values of the R, capital R. This is basically the multiple regression. This is multiple correlation. Multiple correlation between what? Multiple correlation between the response variable 1 and the two independent variable, second one and third one. So it is a correlation between a combined effect of two predictors with the one response variable. So we have the two things among which this correlation is computed. One is what? One is the dependent variable. 2 plus 3 means what? The two predictors collectively, how much correlations these two predictors are impacting with the response variable. This can be tested with the H naught. If this correlation is 0, indicating that these two predictors are not very helpful in predicting the response variable, means this correlation is not significant. Significant. If this correlation is significant, alternate hypothesis R1, comma 2 plus 3 is not equal to 0. So this p-value is 0. How this p-value, we can interpret this p-value. This p-value is indicating that it is smaller than 0.05, means this correlation is significant. So we rejected this null hypothesis. So strong, instead of using the term strong, I can use the term significant correlation exists between the response variable and the sum of all predictors. These two are having a significant correlation. Adjusted R square value is 0.46. Adjusted R square value is an indication of the model accuracy. The model is accurate if we have this number towards 1. If we have this number towards 0, means the model is not accurate. So my number is 0.46. 0.46 is a moderate value. Means we are going closer to the 1, but it is not too high. That number is an indication that the model is accurate or not. How can we explain the adjusted value square, and what is this in number is indicating 0.466? The 0.466 is indicating that these two variables, variable number 2 and variable number 3, the variance in stress caused by these two predictors is 46.6. The 46.6% variation in stress is due to these two predictors, PCOISS and the mastery control. If we, the meaning that the remaining percentage are in the response variable is due to what? So we may include the more variable like age, and social desirability factors, these two variables, if I include, so there is a possibility that this number will be increased. Right now, the remaining number is assumed is due to the variation due to the error. So we have a high percentage of impact of error into the model. ANOVA values, all of you are familiar how these values are computed. This is the variance of due to the known source, and this is the variance due to the unknown source. If I divide these two variances, this is equal to the F statistics. Divide the degrees of freedom 2, because the total number of variables are 3, the degrees of freedom 2. Total number of observations used in this analysis is 425. 425 minus 2 is the degree of freedom of error or the residuals. This, if I look up this number of F observed value into the F table along with these two degrees of freedom, then we will get a p-value. If the p-value is less than or equal to alpha, then the null hypothesis of multiple correlation is rejected, and we can say that there is a significant multiple correlation exists into the model. And multiple correlation means what? It is the correlation between the response variable and the sum of all predictors. Another important table is the table of coefficients. These are the values of the coefficients. As I told you, the multiple regression has parameters. In this analysis, the model can be written as y is equal to b naught plus b1x beta 1 x1 plus beta 2 x2 plus error. If I am writing the estimated model, so we should have to place a y cap on the left side and error should be removed. The first estimate of beta is 50.971. The model can be written as 50.971 is the first value of estimate of beta naught. This is indicated by beta naught into the model, 50.971. And plus, instead of plus, we have a negative slope here. So minus 0.625 x1. X1 is what? Mastery. So you can write down T mast here because you can write down the name of the variable here. But for simplicity, I'm writing x1, the first predictor, minus the second value of the beta, which is beta 1, is minus beta 2, minus 0.175. 0.175 times x2. And I'm not writing the error because I am writing this model as a estimated model. So the difference between the observed model, we do not have a cap onto the observed model and there is an error there. And in the estimated model, after computing these values of beta, we have to write down these estimated values into the model, and the model is represented with the estimated model. Against these three values of beta, we have three p-values. That three p-values are indicated here. So I am writing the three null hypotheses regarding with these three values or these three p-values. One hypothesis regarding with the beta naught. Second null hypothesis is in perception of beta 1 and beta 2. So these three null hypotheses can be accepted or rejected by looking at the p-values against them. The first null hypothesis against the first p-value is beta naught is equal to 0. We have insignificant y-intercept. We have insignificant slope with the mastery control. We have insignificant control with the PCOISS. So these are the slopes. slope with the mastery variable and the slope with the PCOISS variable. And this is not the slope, this is y-intercept. All the p-values are smaller than 0.05. Therefore, these three null hypotheses are rejected, meaning that we have a significant y-intercept, we have a significant slope with the mastery control, we have a significant control with the PCOISS. All the three betas are significant. These three betas must be kept into the model. These p-values are indicating that. Another value in the table is important, and that value is the VIF value. VIF is the variance inflation factor. If there is a cutoff point of 10, if these numbers, VIF values, are larger than 10, then meaning that that specific predictor is causing multicollinearity. So these VIF values are smaller than 1, smaller than 10, meaning that there is no issue of multicollinearity into the model. The multicollinearity is an important issue. Multicollinearity can be checked with the correlation between the two predictors. That can also be checked by analyzing the value of variance inflation factor, which is VIF. If the value of VIF is greater than 10, indicating that that specific predictor is causing multicollinearity issue, and we should have to remove that variable because multicollinearity is impacting that. We have a redundant predictors, and we should have to remove one or two predictors if they are causing multicollinearity into the model. This is PP plot or the probability plot. Probability plot is indicating a linear pattern into the residuals. This linear pattern is indicating that there is no issue of linearity, there is no issue of non-normality into the model. The model, the data should be normally distributed. So this graph is a confirmation that model is not violating the assumption of normality. So we can proceed and trust on the model because the assumption of normality is fulfilled. This graph is indicating that the values of residuals along the zero line, both of the sides below and above the line are equal pattern of the points we have. So we can say that there is no issue of equality of variances into the model, and the errors are randomly distributed. This is the indication that the errors are randomly distributed into the model. All factors are indicating that the model is a better model, but we can enhance the accuracy of the model by increasing the predictors into the model. So we can increase to more predictors into the model, which is suggested in the problem. And that two predictors are social desirability factor, which is TMARLOW, this variable, and another variable that we may include into the model is the age variable. So if I include these two variables and then repeat the entire analysis and observe that, we can observe that the value of adjusted R square will be increased or not. If the value of adjusted R square is increased with the significantly increased with the increasing these two variables, then we can say that these two variables are impacting a lot into the model and into the response variable. If the value of adjusted R square is not significantly increased by considering these two variables into the model, so we can say that the remaining analysis was correct and there is no need to include these two variables into the model. That's all for this presentation. Thank you for watching.